Good afternoon. I am going to just do some example problems from 3.2b. All of the content we already know on 3.2, dealing with finding vertices and intercepts. But what I want to do here is show you some practical applications. These are very similar to the problems you'll have in your homework, so hopefully you'll find them helpful. But please, if there's something you don't understand, don't hesitate to reach out. So this first one, we have a rancher that has 800 feet of fencing to put around a rectangular field. So I would stop right there and draw a picture. This guy's got a rectangular field. He's going to subdivide the field into 3 identical fields by placing 2 fences parallel to the one of the field's shorter side. So this is the picture we've got. Make up variables, what's going to happen here. So I'm going to call these X. They're all equal. And I'm just going to call this Y. We know that he's used 800 feet of fencing. We need to be able to write an equation for that. So there are 4 x's plus 2y has to equal 800 that he's going to use. But what we want to know is we want to know the maximum area. Anytime you see the term excuse me, anytime you see the term maximum or minimum, you're going to use some type of quadratic here. Well, the area of this figure is going to be, x times y, and we want to maximize that area. Well, we have 2 variables here, but notice we have 2 equations. So we can make a substitution here, and I can solve here and get y equals 800 minus 4x over 2, which is 400 minus 2x. And now I can substitute that in for y. So notice I end up with y equals x times 400 minus 2x. I can multiply and I get 400x minus 4x squared, which is a quadratic. This is a downward pointing quadratic, and we don't even really care where it is necessarily. We know it's going to look like that, but notice where the maximum is. This is area. So this is area, and this is x. The maximum or minimum is always going to occur at the vertex. If we can find the vertex, we know where the maximum occurs. I'm going to rewrite this so that it's in standard form. And I know my vertex, which we did in 3.2a, is negative b over 2a, which in this case is negative 400 over negative, this should be a 2, sorry, that was throwing me off. This should be a 2x squared over negative 2 times 2. So our x value comes out to be 100. What you have to decide here, though, is are we looking for x, or the x value of the vertex, or are we looking for the y value of the vertex? In this case, they asked for the area, so we're looking for the value of y. So now we can take 100, plug it in for x, and we get the maximum area is going to be 200, and the dimensions are going to be 100 by 200. That's what they asked for, are the dimensions that give us the maximum area. So we need x and we need y. The second one works a little bit differently because we're looking at revenue. We have a revenue function that's already a quadratic, but they want to know what number of apartments. Well, x is the number of apartments. So again, if they're asking for a maximum or minimum, we know we're dealing with a vertex. So I am going to rewrite this in standard form so that my x squared term comes first. And remember that x value is going to be negative b over 2a. So I get negative 200 over negative 2 times negative 0.4. And when I multiply that out, I get 250. So 250 are the number of apartments. If they asked me for the maximum revenue, then I would take that 250 and I would plug it in. So be careful there to make sure that you are reading correctly what they're asking. Number 3 works the exact same way as number 2. We have a cost function, but notice this time they want to notice the minimum. All that means is our parabola looks like this time, but our minimum is still going to occur at the vertex. I'm going to rewrite my cost function in standard form. And I know that my minimum number is going to occur at the vertex. So negative b over 2 times a. And when I multiply that out, I get that there are going to be 500 tractors that would minimize the cost. And last but not least, on this one, you're going to need the height function. The height function is negative 16t squared plus v naught t plus h naught, which if you remember correctly, we did when we did quadratics back in, I believe it was 1.7. And here we've got a projectile launched with a velocity. This is what our projectile is doing. We're launching it from 45 feet up, and we want to know the maximum height. So we want to know the y value of the vertex. Well, our equation is negative 16t squared plus v naught, they tell us is 64, and they tell us h naught is 45. Once I plug that in, I can find my x value for my vertex, which is negative 64 over 2 times negative 16. And so I get 2 for my x value, but I want to know the maximum height. So I'm going to plug 2 back into my equation here. And when I plug that back in, you should get 109 feet. I hope you guys find this helpful. Please reach out to me if you get stuck on any of these word problems. Again, this assignment is handwritten. You will not do it on Hawks because I want to see the steps you're going through on this. It's only 4 problems, but don't hesitate to let me know if you have any questions. Have a great day.